Hello everyone. Today we're going to discuss the remaining topics in this chapter. So let us begin. So today's first topic is neutralization. Now what is neutralization? Neutralization is a process which can be, you can say, naturally occurring, as well as it can be done in the laboratories under the perfect situation or circumstances. So before going to that, the process, let us first know what is actually neutralization. What is this process? So neutralization means it is a reaction between an acid and a base to give a salt and water. Is known as a neutralization reaction. So basically neutralization reaction, what we require is an acid and a base, and then we react them. Then after reaction, the out product that we get is a salt and some water. So why this neutralization reaction occurs? Because acids and bases react with each other to nullify the effect of each other. Nullify means totally, you can say, disappear, or totally reduces the effect of an acid and a base. After reaction, none of them has their chemical properties left in them. It becomes a totally new substance, that is a salt and also some amount of water. Clear? So this is what is called neutralization. Now we will go further into it. Before that, we should know, we have already learned something about called indicators. So in order to check this process of neutralization, we would also require some indicator. In the last class we have discussed about some natural indicators, but in this neutralization reaction we would require another type of indicator which is synthetically manufactured. It is a synthetic indicator, you can say, not naturally occurring. So the name of the indicator is phenolphthalein. But before that, let us see one reaction of neutralization. You can see here hydrochloric acid, which is an acid, HCl, plus NaOH means sodium hydroxide. AQ means aqueous, in a liquid solution state it is. Then the out product is water, which is liquid, plus NaCl, which is aqueous. NaCl is nothing but common salt that we eat every day. Now, as I've told you just a while ago, that phenolphthalein is chosen as an indicator in neutralization reaction. And how do we detect that whether the out product is acidic in nature or basic in nature? By the color of the indicator. It will turn pink in basic solution and it will turn colorless in acidic solution. Colorless, just like no color, like the water, it has no color. Okay, so how do we do this? There is a activity given in your textbook, but you can, for doing that you need a laboratory. You have to go to the laboratory and do it. But for the time being, you just understand the whole process. What we do is that, first of all, we take in a test tube, about 1/4 of the test tube, we fill it with hydrochloric acid. Then what we do is that we add some amount of sodium hydroxide to it. Clear? Because according to the reaction, you can see hydrochloric acid plus NaOH, that is sodium hydroxide, only then we'll get the out product. But here the main means the basic use of phenolphthalein can be seen. That before doing this reaction, what we do is, first of all, we check the solution, right? We have to check the solution whether it is acidic or basic in nature. So as soon as we take HCl in the test tube, we do not add directly NaOH to it. Before that, what we do, we add 2-3 drops of phenolphthalein. We add to that test tube. We will see that there is no change in the color, because HCl itself is a colorless substance, or a liquid, you can say. So if we add phenolphthalein to it, as we know, phenolphthalein doesn't change its color, it is colorless in case of acidic. So that means HCl is acidic in nature. Now we will add few drops of sodium hydroxide solution. We keep on adding and stirring it with the help of a glass rod. Okay, now after that what will happen is that slowly, gradually, at some point of time, we will get a light pinkish color. I can show you this. You can see here, it was colorless. Carefully see this diagram. It is colorless. You can see it is colorless, and it has turned light pink. Clear? So why this happens? Because we have added sodium hydroxide. Sodium hydroxide to it, NaOH. Sodium hydroxide is what? Is a base. So if you keep on adding the base, the solution ultimately or gradually it turns to a basic solution. So there is a change in color. There is phenolphthalein in it. So the indicator will give us a change. At what point the solution has turned basic. Now in this solution, again if we add a few drops of hydrochloric acid, it will again turn to colorless. So you can see how this phenolphthalein is very much useful in detecting whether the solution has turned acidic or basic in nature. So this is the use of phenolphthalein that we have discussed here. And as a whole, if we will react hydrochloric acid with sodium hydroxide or any base, any acid and any base, if it will react, it will give us salt. And here in this case, the salt is NaCl, that is sodium chloride. And we'll get water as well. Clear? The whole reaction of neutralization and how this phenolphthalein is useful in it. So moving on. Now look here. When an acidic and basic solution are mixed in suitable amounts, both the acidic nature of the acid and the basic nature of the base are destroyed. That's what we have just a while ago we have discussed. So nothing confusion in this point, I guess. So both their means nature gets totally destroyed. The resulting solution that we get is neither acidic nor basic. Whenever we react an acid and a base, the out product that we get, the out product solution that we get is neither acidic nor basic. But yes, remember, if the amount of acid and base is same, remember that amount has to be equal. Only then we will get a neutral solution. Now in neutralization reaction, heat is always produced or evolved. Yes, some amount of heat is also produced. I forgot to mention that in the earlier slide because the point is here. So as we react it, we get some amount of heat. The beaker, if you touch the beaker, you will feel it that it has turned hot. Why? Because some heat is released. Now this heat raises the temperature of the reaction. Yes, the solution that we get is a little bit hot because the acid is also neither hot in nature or neither the base, but the out product will turn something hot in nature. It will evolve some heat during this reaction. Now in neutralization reaction, as we know, we get a out product that is called salt. So in the earlier case, we got HCl plus hydrochloric acid and sodium hydroxide. We got sodium chloride as the salt, that is the common salt that we eat. So in every neutralization reaction, we will get a salt and some amount of water and also some heat. This is, we can say, this is general phenomena. Now the salt may be acidic, basic or neutral in nature. Yes. In the reaction that we have shown here, you can see this reaction, HCl plus NaOH will get H2O plus NaCl. So NaCl is neutral in nature. But it is not that in all the cases the salt will be neutral in nature or it will not be acidic or basic. In some salts are also there which are acidic in nature and some are basic in nature. So those salts we can't eat because too much of acid in our body will be also harmful and too much of base also will be harmful for our body. Clear? So that's why we prefer this NaCl because it is neutral in nature. It is neither acidic nor basic. Clear? Now moving on, some neutralizations in everyday life. Neutralization reaction occurs in everyday life. We might not know, but it occurs. So first case is indigestion. We all know indigestion, stomach ache and all these things. So why it happens? Our stomach, as we know, it contains hydrochloric acid, which helps in digestion of food. But what if this secretion of hydrochloric acid becomes more in our stomach? Then it causes some problem in our stomach. It causes pain in our stomach. So why does this happen? This is due to indigestion. Or you can say due to high amount of hydrochloric acid. We say that acidity. So in that case, how this neutralization reaction can help is that since that is an acid, hydrochloric acid, so to reduce its effect, we have to use something called base. So base is, you can say basically we use an antacid, which is a base. Antacid is that digen, which you use, digen liquid, that is an antacid. It consists of milk of magnesia, which is basically nothing but magnesium hydroxide. So magnesium hydroxide is a base. So this base helps us to reduce the acidity. Clear? Now next is ant sting. Now you know this ant, they bite, it is very painful even though they are very small in size. Why it happens? Because the sting of the ant contains a formic acid, so it is very painful as well as it burns, it gives a burning sensation. It contains formic acid. Now what happens is that when an ant bites, it injects this formic acid into our skin. Now as a result, itching occurs, burning sensation occurs, pain occurs. So to reduce this, what we can do is that we can rub some moist baking soda. Baking soda is sodium hydrogen carbonate, so it is a base. Or calamine solution, we all know what is a calamine solution used for this beauty, it is a beauty product. So it contains zinc carbonate. So zinc carbonate also a base. So in both these cases, you can see how acidic reactions can be neutralized with the help of a base because of this neutralization process. There are other two examples you can see. Soil treatment. The farmers, the plants might not grow well if the soil is acidic in nature or basic in nature. And it happens due to use of excessive fertilizers. So it turns the soil acidic. So what to do is that if it turns acidic or basic, the plants would not grow well, will not get our crops. So we have to treat it accordingly. If it is too much of acidic in nature, we have to add base to it. So we can add quicklime or slake lime. Quicklime is nothing, it is that white powder, chuna, which is a chuna. So we add to it. Why we add to the plants? Because chuna is a base. It can help to reduce the acidic level of the soil. And if it is basic, we can add some organic matters like leaves, dead leaves, this dead branches, then even the cow dung, which is used as a manure. We can add all those to reduce the basic nature of the soil. Now the last but not the least, factory waste. We know factory waste are very toxic and poisonous because it mainly consists of acids. So before throwing it into the water bodies like the rivers or the oceans, we have to treat it properly in the waste treatment plants. And we have to neutralize them first of all by adding some basic solutions and all those. So by neutralizing its nature, only then we should throw it into the water bodies. Otherwise this aquatic flora and fauna will be affected, or it will cause harm to the fishes and all the aquatic animals. So now you understood how this neutralization reaction helps in everyday life to keep a balance between the acidic and the basic nature. So you can go through your textbook. This brings us to the end of the chapter. You can again go back to your textbook. You can see the activities and all those things and read for yourself to better understand this chapter. So I hope you have understood today's class. So thank you and have a nice day.